Alrighty, hello. Today what we're going to talk about is the slope of a line. Alright, so what we're going to hopefully be able to do is calculate the slope between any two given points on the coordinate plane. Alright, so what is slope? Right, a slope is a constant rate of change, right? It's, a line that's traveling, kind of tilted upwards, tilted downwards, tilted way down or way up, somewhere in between. So the way that we're going to be able to calculate the slope is by using this slope formula. All right, so I'm going to kind of zoom in a little bit there. And this slope formula is something that's going to be real important to be able to use. All right, so slope formula, we use m, right? That's the letter we use to represent slope. So m is equal to, and then we're going to set ourselves up with a big fraction with some subtraction on the top and the bottom. All right, so I like to call this the skeleton of the slope formula, right? This is the bare bones. This is before we plug numbers in, right? This is like the basis of it. After that, what we've got is that we are going to have y2 minus y1 on the top of there. And then on the bottom, we're going to have x2 minus x1, right? So the x1, y1 and the x2, y2, right, they kind of match with colors, right? The reason why is because to figure out the slope, we need to be talking about 2 points. So those 2 points that we're going to use, right? So point 1 is going to be x1, y1. Point 2 is x2, y2. Right? And if you haven't ever seen those little 1s and 2s at the bottoms of these, don't be freaked out, right? It's just, when we talk about points, we use x and y, right? X for the x part of the coordinate, y for the y part of the coordinate, right? So all we're doing is we're giving them a little label, right? x1 and y1 go with point number 1. x2 and y2 go with point number 2, right? So thinking about rate of change, right? What do the words rate of change kind of make you think of, right? So rate of change is how fast something's changing. Slope is telling you basically the rate of change, right? And they're pretty much, we could say that they're the same, right? Finding the slope of some sort of graph is the same thing as describing its rate of change, right? So let's take a look at a graph. Let's kind of work through a couple problems here. We want to find the slopes of these different segments of this line. All right, so the first one here is segment A running just like that. All right. What we want to do is we want to figure out what the 2 points are on it, right? So the first one, way over to the left, that point is 0, 6, right? It's on the y-axis, right? So it hasn't got any x at all, so we have 0. And then the second part of it is that 6, because we went up to 6 for y. The second point of segment A right down there is going to be 1, 3. Okay, so what we're going to do is we're just going to kind of transpose those over here. So our first point is 0, 6. Our second one is 1, 3. Right? I'm just going to clean up our graph a little bit since we're going to keep on using it. So to find the slope of segment A, we're going to need to use those 2 points. And the way we're going to do it is we're going to use our slope formula that we just talked about. So for our slope formula, right, this first point that we had, let's call that x1, y1. The second one, let's call that x2, y2, right? You don't need to put the labels on there, right? As you get better and better with these, you won't need them quite as much, but it's never a bad idea at the start. All right, so I'm going to start off by writing out my skeleton for the slope formula, right? And then all you got to do is plug the numbers in where they're supposed to go, right? So the slope formula was y2 minus y1 on the top. So we have y2 minus y1. Same thing on the bottom, it's x2 minus x1. Right? So we go ahead and do that. Now all we have to do is simplify this fraction, right? And again, don't worry about the fraction piece of it, right? It's just a little bit of division. So 3 minus 6 up on the top is going to give us negative 3. 1 minus 0 on the bottom is going to give us 1. Right? And we could leave our slope just like this, negative 3 over 1. It's a perfectly fine way to do it. Right? If you wanted to, we could simplify that. Negative 3 divided by 1 is just negative 3. Right? Either one of those is going to be A-okay. Okay, let's try it again with segment B. So for segment B, right, again, I have to figure out what the 2 points are. So this first point that it has is the same as the one we just had for slope or segment A, right? That's the 0.13. For the second one, right, that is the 0.22. All right, so again, what I'm going to do is I'm going to take those points, pop them over here just so we have it all on one screen. All right, and then we're going to plug those into the slope formula, right? So while I'm kind of tidying up the graph here, if you wanted to start writing out the skeleton for your slope formula, it's not a bad idea because that's what I'm going to do. All right, we've got x1 and y1. We've got x2 and y2. And then our skeleton looks like this. M equals a big fraction with some subtraction on the top and the bottom. All right, and then again, once we do that, it's just a matter of plugging things in. It's y2 minus y1 on the top, x2 minus x1 on the bottom. So up top, 2 minus 3 gives us -1. 2 minus 1 gives us +1. And again, we can leave it as -1 over 1, or we could simplify that to just be -1. All right, either one will work. All right, for segment C, right, take a second, see if you can narrow down which 2 points we're going to use for segment C. All right, so hopefully you did that. All right, we're starting at 2, 2, and then segment C ends over there at the point 3, 4. All right, so again, all I'm going to do, I'm going to take those 2 points, I'm going to write them over here. We have 2, 2, and we have 3, 4. And we'll set ourselves up a skeleton for our slope formula. Okay, so again, same thing. Once we have the skeleton set up, you plug those numbers in where they're supposed to go. All right, so in this one, y2 minus y1 up on the top. We have x2 minus x1 down on the bottom, right? And again, you can label these if you want. Sometimes I still do it just to, make sure that I'm not writing down the wrong number in the wrong place. Right, so our x1 and y1 are together, our x2 and our y2 are together, right? Plug them in, and then we're good to go. So 4 minus 2 up top is just going to be 2. 3 minus 2 is 1 on the bottom. And then 2 over 1 is perfectly fine, or we can simplify that to just be 2. Okay. One last segment, segment D. All right, so this one, starting point is that point 3, 4. Its ending point is over at 4, 4. All right, so 3, 4 and 4, 4 are what we're working with. 3, 4, 4, 4. And again, you can label these if you think it might help. All right, set up our slope formula skeleton. All right, as I'm recording this today, it's starting to get a little bit towards October. It's going to be spooky season, so we're going to work with skeletons. All right, so up top, we've got y2 minus y1. On the bottom, we have x2 minus x1. All right, so up top, 4 minus 4 is just 0. Right, 4 minus 3 is 1 for the bottom. And then 0 divided by 1 is just the exact same thing as 0. Right? Whenever you can turn it into 0, right, when it's 0 over something else, we wouldn't really keep it as 0 over 1, right? In this case, we would definitely want to simplify to just be 0. Okay. So we can have all sorts of different slopes, right? We had some positive ones, we had some negative ones, and then we also had 0. All right, there's another type we'll talk about a little bit later on. So what we're hopefully noticing is that if the slope is different, then the rate of change is also different. All right, so if we look back at this graph that we were just working on, right, we can see that at first, it descended pretty quickly, right? It kind of went straight down on that A part, and then it started to slow down with its descent a little bit around B, and then it shot back up for part C, and then at D, everything kind of leveled out, right? So it's talking about that rate of change, changing, right? As the name implies. Right, so let's take a look at some other, graphs with some different types of numbers in them. Right, these ones are going to have some negative numbers floating around as part of the points. Okay, so When you're choosing which one of these is the x1, y1, and which one is the x2, y2, right? Which one's the first and which one's the second point? You can choose either one, honestly, right? But what I find is that if you don't like working with negatives too much, your life will be a little bit easier if you take the point that's further to the left, right, and make that your x1 and y1, right? So that's what I'm going to do here, right? x1, y1 is that one. The one that's further to the right on your graph, I would call x2, y2, right? What that's going to do is it's going to make your fractions a little bit nicer to work with as we go, right? If you wanted to switch them around just to see what would happen, you should end up with the same answer, right? If you want to give it a shot, that's no problem. All right, but all I'm going to do is I'm just going to use our slope formula again. We have m equals that skeleton there. Up top, we have y2 minus y1. Then on the bottom, we have x2 minus x1, right? And this is where that skeleton gets kind of important, right? You'll notice that on the bottom, I have 15 minus -3. That's exactly how it should be, right? We can turn that into one big old plus sign down there, but we want to make sure that when we bring x1 is -3. We want to not forget that negative, right? Another way to think about it is that those subtraction signs in our skeleton are built into the formula, right? If we bring in a negative number, we still need both bits of negativity there. So after that, we just kind of run through it. 10 minus 7 up top gives us 3. 15 plus 3 on the bottom gives us 18, right? And it would be perfectly fine to leave it as 3 over 18, right? When we've got something as a fraction like this, it's definitely going to make our lives easier as we go to simplify it. So 3/18 is the same thing as 1/6, right? So this is hopefully where we want to get to, 1/6. All right. Let's take a look at another one. And actually, by let's take a look, what I want you to do is pause here, try this one out. All right, so hopefully you did that. Right, again, what I'm going to do is I'm just going to choose the point that's further left. That's going to be my x1, y1. And then the point that's further to the right is going to be my x2, y2. Right? Again, if you chose them in the reverse order, it's not going to make a difference, right? We should end up at the same answer at the end. All right, so my slope is equal to, right, we've got y2 minus y1 up on the top. And then we've got x2 minus x1 on the bottom. Okay, so up top, 3 minus 12 is going to give me -9. 18 minus 3 on the bottom is going to give me 15. Right? And again, -9 over 15 is something that we can simplify, right? If you chose the points in reverse order, right, you said that, the x1, y1, and the x2, y2 were flipped, right? Then your answer probably at this point looked something like 9 over -15, right? And again, that's the exact same thing. You're not doing it wrong. It's just another way for it to look, right? Our simplifying step, right, -9 over 15 can be simplified to be -3/5, right? And then again, if you simplified and you chose your points in the reverse order, right, your answer could look like this, 3 over -5. Or, we can just pop that negative out into the front of the fraction and just call it -3/5, just like that, right? Any of those 3 over here would be perfectly fine, right? They all mean the exact same thing. Okay, so slope formula is not too bad, right? But we have this alternate way to figure out slope that you've probably heard about in the past, right? So the alternate formula for slope is rise over run, right? Sometimes when we're dealing with a negative slope, I like to call it fall over crawl, right? But rise over run is the one you've probably heard before, right? It's where if we have the points on a graph, we can just kind of count it out and see where we're going. Okay, so let's give it a shot. We want to figure out the slopes of these lines, right? So let's focus on one at a time. Let's go ahead and let's give this one a shot. So to figure out the slope of this one, right, what I need to do is I need to find 2 good points to work with. And what I mean by 2 good points is that, we don't want to choose, for example, this point over here, because it's going to be hard to count from, right? It's between 2 different squares. It's not really going to be that easy to work with, right? I especially don't want to choose something like the very tip of this over here, right? Because that's floating out in the middle of nowhere. I can't really count for that. But if we find something that's right on the grid lines, like point D and point E, right, then those would work just fine. All right, so to figure out the slope of that line there, all we're going to do is we're going to go from the left to the right. I'm going to go from point D, and I'm going to rise 1. All right, so if I'm thinking about my rise over run, my rise was 1. Now I've traveled up to, just this point right underneath A. Now I need to run until I hit the next point. 1, 2, 3 over. So my run was 3. So that's what we're trying to do. We're trying to basically connect the dots in the shortest amount of steps, just like that. Right? So to get from D over to E, right, we had to rise 1, run 3. We could even do it with E and F, right? We would rise 1 and run 1, 2, 3. Right? We would end up with the same thing, which is good because it should stay constant. We should end up with 1 over 3 no matter what. Okay. As for the other one, right? Again, let's choose 2 good points, right? I'm going to choose B and C. Actually, let me change colors real quick. So it's a little bit easier to see what's going on. So B over there, C over there. And again, I'm thinking about my rise and my run. All right, so going from B to C. Right, so the rise part, right, going up or down, I'm going to go down 1, 2, 3. So my rise is sort of like 3, right? But I went down. So the way that we're going to represent that is we're going to call it -3, right? Makes sense. If you go up, it's positive. If you go down, it's negative. As for my run, now I'm traveling over 1, 2. Right, so my run is 2. Right, so the slope of that first line we found was 1/3. Slope of this second line is -3/2. And that's it. That's all we got to do for rise over run. So if you have a graph and you already have points on it, it's pretty easy to get the slope this way. Right? Let's try it out with these ones. Right? So let's start off by doing this line that has this point that I just put in red and goes over to Q. Right? And again, I'm choosing these points because they are like right on these grid lines, right? They're real easy to count from. I don't have to be like, oh, is this halfway there or is this 3/4 of the way? Right? No, they're nice and easy to go. So my rise and run for those ones, right? Again, I'm starting from the left one, I'm going to the right one. I'm rising 1 and I'm running 1, 2. Easy peasy, right? 1/2 is the slope for that line. All right. Try taking a second, figure out what the slope for RS is. All right, so hopefully you did that. And again, we're doing rise over run. Right. This is one that, again, you could call fall over crawl because it's going downwards, but either way works. Right. So if I'm starting from somewhere, actually, let's start at R, and then let's go to S. All right. So going from R, I'm going to go down 1, 2. So going down means that my rise is -2. As for the run, I'm now going 1, 2, 3, 4 over. So my run is 4. So -2/4, you might be noticing, is the same exact thing as -1/2. Right? If you chose this point that I just put an X through, right, you probably ended up with just -1/2 right off the bat. Right? But that's showing us that no matter, which points we chose, as long as they're on the same line, we should be able to end up with the same exact slope. Okay? So, I have some good news. If you've been looking at 4 and 5 and you're like, ew, I don't know about that, we're not really going to run through them too much. I am going to kind of give you a quick overview of what we would do to solve problems like these, but we're not super duper worried about them. So if we were trying to use slope to determine if the points -2, 2, 3, and -10, 9 were on the same line, then all we would do is we would pair them up, right? And then we would figure out the slopes. So we would want to make sure that the slope between these two matches the slope between these two, right? Because it's a constant rate of change when we're talking about slope. So if the slopes match for those two different sets of points, then we can call them all on the same line, right? Same thing goes for these ones, right? If the slopes between -3, -5, and 0, 1 matched with the slopes between 0, 1, and 2, 5, then they'd all be on the same line. Right? I am going to fill these out before I post the PDF to our Google Classrooms. If you did want to check and see how these would be done, it will be up there. Right? But we're not super duper worried about it. If you don't want to copy it down, that's okay. Right? We got a little bit left to talk about. Right? These are the funky slopes. All right. So we're going to start by graphing the line y equals 2 here. Right? It's like, oh gosh, we're already graphing. So y equals 2 is going to be a weird type of line. So what I want you to think about is that lines are just a bunch of points. So if I'm thinking about a bunch of points where the y is equal to 2, let's just write some out, right? If the y is equal to 2, then that means that in all of these points, I can fill in a y of 2, all right? After that, it doesn't tell me what the x has to be, so let's just throw some numbers in there, right? Let's say like -4. This one could be 10. This one could be 0. This one could be 3, right? All of those points are going to work for that line y equals 2. So let's take a look at where that's going to look like. If I graphed all those points, right, -4, 2 is going to be right there. 0, 2 is going to be right in the middle. 3, 2 is going to be over here. And then 10, 2 all the way over to the right. Right? All those points now make a straight line. All right, so I'm going to try my best to draw a straight line on here. Let's see how this goes. Wow, look at me go. Not too bad. All right, so when we're drawing a line, you might notice that I, extended this piece over here all the way to that edge of the graph. Right? Use the entire graph. Right? One other thing we want to do is that lines go on forever, so let's put little arrows at the ends. All right? So we have now graphed the line y equals 2. Right? The next part is asking us to find 2 points on the line. Easy peasy, right? We already had some from right up above there. Oy, oy, oy. All right, so let's choose some easy looking ones, right? 0, 2 looks pretty easy. And so does 3, 2. All right. So what we're going to do is we are then going to calculate the slope of the line. Right? You might be able to tell just from how it looks, right? But let's kind of walk through it, right? So to calculate the slope of the line, what I'm going to do is I'm going to call that first point x1, y1. I'll call the second one x2, y2, right? We're going to calculate our slope using the slope formula. Up top, we've got y2 minus y1. On the bottom, we've got x2 minus x1. Okay. When we do that, 2 minus 2 up top is 0. 3 minus 0 is 3. And then 0 divided by 3 is just 0. Right? So, again, you might have been able to tell that from the start, right? It's not changing. The slope is 0. It's staying the same the whole way through. That's going to tell us about the slope of all horizontal lines, right? So whenever you have a horizontal line, the slope is 0. M equals 0. That's all we got to do there. Right? Let's try another one. Let's graph the line x equals 2. Right? Let's start off the same way. Right? So again, if I wanted to choose some points to throw on the graph, and we know that the x has to be 2, that means that I can fill all of this in. Right? All of those are going to be 2. After that, it doesn't really matter what we choose for y's. Right? So let's choose like -10. 0 was a good one last time. Let's choose like 4 and 9. Right? So all of those points have an x where the x is equal to 2, right? So they will all work for the line that we want to graph. So over here on the graph, we're going to graph 2, -10, way down there. 2, 0. Oops, that's 1, 0. Let's try that one again. 2, 0. 2, 4. And 2, 9. Right? So again, you're noticing that these make one big line together, right? They all line up. And let's see if I can draw another good line here. Wow, look at that. It's a little bit off, but that's okay. So again, using the whole graph, putting arrows on the ends to make sure we use our space wisely and show that it goes on forever. And then we're going to do pretty much the same idea. We're going to find 2 points on the line. Right? So for this one, let's choose like 2, 4. And 2, 9. right? And let's see what happens when we calculate the slope. Right, so this first one I'm going to call x1, y1. The second one I'm going to call x2, y2. To calculate the slope, we've got m equals this big fraction with the subtraction. Right? Up on top, we've got y2 minus y1. On the bottom, we've got x2 minus x1. All right. So when we do that, 9 minus 4 is equal to 5, and then 2 minus 2 equals 0. And oh my gosh, oh no, oh dear, oh no, 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 no. So we have a problem here. We cannot divide by 0, right? This right here is bad. Right? So we cannot divide by 0. It just doesn't work, right? It's one of those mathematical truths of the universe. You can't divide by 0. It's like if I had 5 cookies and I wanted to split them into 0 equal groups, where do they go? They just poof out of existence. It doesn't work that way, right? So we cannot divide by 0. So the way that we talk about the slope of vertical lines is that, we can't, right? So what we do is we call it undefined, right? Our human brains don't have a way to really comprehend what's going on, so we just call it undefined, right? We can't figure out what the slope is, right? That's really all there is to it. So whenever you have a vertical line, it's undefined, right? Horizontal lines have a slope of 0, right? And actually, I guess you might have been looking again at 8 and 9. We're going to worry about those at a future date, right? For right now, that's actually it. That's all I got to say about slope for now. And you're like, oh my gosh, thank you. All right, so be sure to check on Google Classroom for any additional stuff, and I will see you next time.